Good morning, guys. I'm here to help you with a couple of your homework problems. I want to make sure you are getting this. I know that this projection portion can be a tough section for vectors, so I am going to do a couple of problems from the projection part of your homework. I am going to do number 28. And you had to do 27, 28, and 29. I hope that this will help you understand how to find a projection a little bit more. And then I'm going to do a word problem on the next slide. So for 28, I chose this one because it is in linear component or composition form, which means that they are not in component vector form, but it's easy to put them into component vector form. So you can do u equals 6, 1, and v equals negative 3, 9. So if you want to put it in component form first, if that helps you out, go ahead. And then there are two steps to these type of problems, and that's what makes them difficult, but if you just follow the process in your notes, you'll be able to do it when it comes test time. So one, we are going to find the projection of u onto v, and then two, we are going to write that u vector as the sum of its projection and the projection's complement. I'll explain that a little more when we get to that section. So first we're going to find the projection. And I'm going to write that formula. So the first part is finding the projection of u onto v. And the formula is u dot v over the magnitude of v squared times the vector v, because the projection is a vector. It's a projection vector. So we need u dot v, and we are going to need the magnitude of v. To find u dot v, we are going to multiply 6 times negative 3 plus 1 times 9, and that equals negative 9. To find the magnitude of v, we take the square root of negative 3 squared plus 9 squared. And that equals the square root of 90, which I know you could simplify down to 3 square roots of 10, but since we're going to be squaring it in the formula, we aren't going to bother doing anything to that square root. We're just going to remove it later. So now we can put these two things that we found, into the formula. So that is negative 9 over square root of 90 squared times vector v, which is negative 3, 9. Before we distribute, we're going to simplify this portion first, and that will simplify down to negative 1 over 10, because the square roots and the square cancel. And then it will be easier to distribute now as the scalar to the vector. Don't forget, you only do multiplication on the tops, not the 10. So this is now going to be the new vector 3 over 10 and negative 9 over 10. This vector is the projection vector of u onto v. And the second portion wants us to find u as the two components of the projection, which is w1, so that is w1 that we found, plus its complement, w2. So we are defining u as the projection vector and its complement, because a vector has a horizontal section and a vertical section, and if we are making this projection vector our new horizontal, then we need to find the complement, which is the new vertical. So we take our u and w1 and plug them into this formula. So that means we are going to take 6(1) equals 3 over 10, negative 9 over 10. solve for W2. So W2 equals 6, 1 minus 3 over 10, negative 9 over 10. And when you do the subtraction, if you're good with fractions, great. If you're not, stick it in your calculator and get the fraction answers. So 6 is actually 60 over 10, so 60 minus 3 will be 57 over 10. And 1 is 10 over 10, minus negative 9. 10 minus negative 9 is 10 plus 9, which is 19 over 10. So there's your new W2. But our final answer has to be U as the component of those two vectors. U is 3 over 10, negative 9 over 10, the projection vector plus its complement, 57 over 10, 19 over 10. Okay, so that was 28. Yes, those are big problems. So you're probably only going to have one of these on your test. Okay, so the next we are going to do number 34 because it has Isabel in it. Yay, Isabel. Okay, so what you do, you want to draw a picture. This will help you out. And it's about Isabel going down a slide and stops herself when she notices somebody at the bottom of it. Okay, so you draw a picture, and it doesn't have to be accurate. We're figuring out the force to keep her from sliding down. So we're figuring out this force vector V when the slide is 53 degrees and does not like little things on here. Try again, 53 degrees, and that's fine. All right, and she weighs only 62 pounds, wow. Okay, 62 is the force going down, and I'll go ahead and draw. She stabbed herself. Oh, that's terrible. On the slide. Okay, so she stopped herself, and so that's where she is, and so 62 is the force going down, and we're looking for the force keeping her up there. So what we are going to have to do is get the two vectors, and then we're going to find the force of her weight pulling down, but we're going to find it in the V direction, and then we're going to have to reverse it because it's the inverse. So I'll explain it as I go through, and hopefully it'll make a little more sense. So first we'll find the two vectors. And if you remember, when we have a problem like this, we want to make a coordinate plane so that we can easily figure out what vector F would be. And that vector is going to be 0, negative 62. The rest, we're going to need a vector for V. So the first thing we're going to do is find V as unit vector. And so that means we can have the magnitude of V. So it's going to be the same vector, but it's the unit vector of it, which makes it easier for us to work with, because the magnitude of a unit vector is 1. And so now we can find the unit vector itself by the component of 1 times the cosine of 53 and 1 times the sine of 53. So we're getting a smaller, the unit size version of vector V. Okay, and that would be, that turns out to be 0.6, here, 0.6.8 is the new vector, the unit vector V that we're going to use. Okay, so the next thing we're going to do is project F onto V. So we're going to move, let me do another color here. We're going to figure out what F projected onto V is. So that's what we're doing. We're finding the projection of f onto v. And you can see that it's going in the opposite direction. All right, so let's go ahead and do what that process means. We need the f dot v first. We need that dot product. And so that's going to be with these two vectors, 0 times 0.6 plus negative 62 times 0.8. And that comes out to be negative 49.6. And that is going in the wrong direction. We want the vector to be going, we want the v vector to be going up. So we're going to make it positive. And since we would just be dividing by the unit vector magnitude of 1, it stays the same number, and we don't have to multiply it by v because it is v. So this is it. This is our answer. Basically, we just had to find the dot product portion of the projection, and that changes the force. That's the force holding her up. I hope that made it a little clearer, and you can probably do 33 now based on that or based on the notes. Try to get those homework problems turned in today, and we will also be starting on the review problems that I'm going to post, but I'm not going to take a grade on those review problems. And so you only know that for now if you watched this video. I will be talking to you later, and later in the week I am going to try to do a group video with us. So I hope you will join us for that. Talk to you later.